Hi guys, welcome to the fifth session on Modulus. In today's short video of mine, we are going to look at an aspect called inequalities in Modulus. So by now you already have gone through the videos where I discussed in detail about the meaning of modulus, the distance aspect of a modulus, the mathematical definition of modulus. We have also seen how to deal with questions that have modulus. We have seen maxima, minima. So all of these have been done. In the last one or two things that are left out for us to cover in modulus is today's topic called inequalities. It's not a great deal. It's a small rule that you have to remember for inequalities in modulus. So let's go ahead and see what this rule happens to be. So when you're dealing with inequalities in modulus, we'll start by understanding the very fundamental basic inequality. So if you're talking about mod x, which is your simplest form without any other constants in it, if I just write mod x, it is less than or equal to any number. Let us take an example. If I write mod x is less than or equal to, let us say 6, then this will be written in the form of minus k to k. So in this case, my constant is 6. So I will rewrite this without the modulus. The inequality will be written without the modulus as minus 6 less than or equal to k less than or equal to 6. Okay, please keep in mind, this is only when you're dealing with less than or equal to or less than. For greater than, which is where we come here, when the greater than or equal to or greater than sign comes into play, and if you write, if you have mod x is greater than or equal to 5, then this will be broken into two parts like this. What are these two parts? If you understand this carefully in terms of the example, you will write this without the modulus as x is greater than 5 or x is less than or rather greater than or equal to or x is less than or equal to minus 5. So what you mean is in the number line, you will have minus 5 and 5. Your x is in this either greater than 5 or x is less than minus 5. This is how you break modulus inequalities. Okay, so please keep this in mind. We will see the application of this in the next one or two slides. We will see short questions on how to deal with it. All right, so let's try to put into practice what we have just seen in terms of rules. I'll take a simple example to explain how do we solve this question. So let's take this particular question in mind. There are two moduluses. First, there is a modulus here, and then you're adding 5 to it. And then overall, there is another modulus. So what I will do is I will treat this entire thing as x, or let's use another variable y. So I will write mod y is greater than h. That is what has been given to me. So this can be broken down as y is less than minus h or y is greater than h. This is the first way in which I will break the modulus. This is the rule that we have just seen. But what is your y? Your y is not y. You now replace your y with your original. So you have 2x minus 5 modulus plus 5 less than minus h, or you have 2x minus 5 modulus plus 5 greater than 8. Now simplify this and simplify this normally. So what do you get? You get mod 2x minus 5 less than minus 13 or mod 2x minus 5 greater than 3. Now, if you observe here, a modulus is less than a negative number. It is never possible. It is never possible. So this gives no solution here. Now, had it been a positive number instead of minus 13, had it been a positive number, you would have required to solve it and get a different answer there. But here right now, there is no solution for this part of the answer. Whereas on the right side part, this is again in the format of mod a greater than 3. This gives you a is less than minus 3 or a is greater than 3. Once again, what is your a? Your a is 2a minus 5. So you have 2a minus 5 less than minus 3 or 2x minus 5, or 2x minus 5 greater than 3. So which gives you x is less than 1, or x is greater than 8 by 2, 4. So you got finally two answers. And because it is a or, it means it is the addition of these two answers. If you remember, in inequalities, we have seen the meaning of or and we have seen the meaning of and. So here it is or. So your final answer is x is greater than 4 or x is less than 1. So mathematically, you can write it as x belongs to minus infinity comma 1 union 4 comma infinity. This becomes your answer, right? So guys, this is about your basic inequalities using the rules that we have just seen. We will also see one question where the question does not have a single modulus, but it has a mixture of two moduluses now. So here we cannot use the rule directly, because the rules that we have seen for the inequalities deals with a single modulus being compared with greater than, lesser than to a constant. But here we have two modulus. The only way to deal with this is by the number line. So you have to look at the boundary points for this modulus. So equate each modulus to 0. You will get your two boundary points. If you remember, we have discussed boundary points in your inequalities also, and we have discussed this in our modulus first two classes also. So there are three regions, and you're supposed to solve this inequality in the three regions. It is as simple as the theory that we learned for solving of modulus equations. But instead of an equation, now we have an inequality. So let's go ahead and do the same thing. I will look at the region number 1. Okay, in this region, my answer, basically my modulus, both modulus are always positive. Okay, now if you forgot how to know that, or how do you check for the modulus is positive or negative, take any one number from this region, put in the modulus and see. If I take x equal to 10, which is in this region 1, if I take x equal to 10, you will see that this is positive and this is positive. Both are positives. So if one number makes the modulus positive, then every number in that region makes it positive. This is a theory that we have seen already. So the inequality becomes x plus 3. I can take out the modulus, minus x plus 2 greater than 5. And x gets cancelled. You will get 5 is greater than 5. Clearly, this is false. 5 is not greater than 5, which means there is no solution here. No solution here. In fact, if you notice, 2 also will not be an answer. Because if x equal to 2, you will notice that 5 is greater than 5, which is again not acceptable. Let's go to the second region. This is my second region now. Once again, you have to rewrite your inequality in the second region. Let's take x equal to 0 and substitute and see. If you put x equal to 0, this will be positive, but this will be negative. Which means without the modulus, if you want to write, the first modulus will be written as it is. But the second modulus sign will change. This gives you 2x greater than 4, or x is greater than 2. Now remember, x is greater than 2, but you are in the region from minus 3 to 2. So your answer is supposed to be within this minus 3, less than or equal to less than x, less than 2 only. In this region only you want answers, but you got an answer beyond the region. It means once again there is no solution here. And if you go to the final region, which is your region 3, and if you observe for what is happening for the modulus, you will see that both moduluses will become negative. So it will become minus x minus 3 plus x x minus 2 greater than 5. Okay, so your x will get cancelled and you will say minus 5 is greater than 5. Clearly, it means there is no solution again, because minus 5 is not greater than 5. So there is no answer here. So effectively, we have checked all the points and there is no answer for this inequality. Now, normally what happens is when you get an answer, you have to take only that part of the answer which fits into the region. For example, in this second region, had I got this x instead of x greater than 2, had I got something like x is greater than 1, had I got it like this, it means I would take the answer as x is greater than 1, but it is stopping at 2. So I will write x belongs to 1 comma 2. This is what I would write. But right now in our question, it is stopping at this x greater than 2. Hence, there is no solution. Right? So guys, with this, we bring our modulus of inequalities to an end. So I hope you guys enjoyed this short video. In fact, I told that this is going to be the last video, but there will be one more video, and I'm going to talk about the graphs of modulus. All right. Thank you guys. See you in the next session.